Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to how to title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be drawing quadratics so we can complete the square and how to approximate the solutions. That means that we're not going to have a nice square root. The second part of our goal is going to be how to deal with an odd b value. So let's go ahead and jump into our first goal, but before we do that, we need to review some things about how to approximate square roots. Now I have a list of numbers ordered so that we have that 1 is less than 2, and 2 is less than 3, and 3 is less than 4, and 4 is less than 5, and 5 is less than 6, and 6 is less than 7, 7 is less than 8, and 8 is less than 9. I could have stopped and said, you get the idea. Well, anyways, what we can do is we can actually take the square root of each of these numbers, and we will still be keeping this order. And so if I was to square root every number, there's some numbers that we're going to know the square root of, and there's other numbers that we will not. And so by us figuring out where the numbers that we do not know the square root of, where they fall, that'll give us the ability to approximate the square roots. All right. I know the square root of 1 is 1, so I know that 1 is smaller than the square root of 2, there's a class starting, and that's smaller than the square root of 3. I know the square root of 4 is 2, so what this means is the square root of 2 and 3 are between the values of 1 and 2, so you approximate. Right? Square root of 2 is 1.5. Square root of 3 is 1.6. As long as the values are somewhere between 1 and 2. I don't know the square root of 5, so I'm going to write that as it is. I don't know the square root of 6, so I'm going to write that as it is. I don't know the square root of 7, so I'm going to write that as it is. I don't know the square root of 8, so I'm going to write that as it is. I do know the square root of 9, and that is 3. So what this means is the approximation of any of these square roots must fall between the values of 2 and 3. So you could say this is 2.3, 2.4, 2.5, 2.6. Approximation. There's no such thing as an exact approximation. As long as you're within a certain set of values, you should be okay. All right, so I would like to now go ahead and move into solving, completing the square, and approximate the solution. And remember, I'm going to hit my first part of my goal, how to approximate solutions. All right, so I'm going to draw this as a square, figure out what I need to add or take away, and then complete the process. So here I have the x squared. I cut my b value in half, so that means that I need 3 x's on each side. And I have 4 little guys. Well, I can see that I'm actually 1, 2, 3, 4, 5 little guys short of having a square, so I need to add 5 guys to complete my square. So we're going to need to add 5 to complete this. So I'm going to add 5 to you, and I'm going to add 5 to you. I'm going to bring this over to the side a little bit and have some more room to work. So now we're going to get x squared plus 6x plus 9 is equal to 5. Well, this is not very well drawn. That's okay. I know the side lengths of my square. And remember, my side lengths multiply to my area. So I know that the side lengths of x squared plus 6x plus 9 is going to be x plus 3, because that's this length, x plus 1 plus 1 plus 1, times the same value of x plus 3, x plus 1 plus 1 plus 1. But x plus 3 times x plus 3 is the same thing as x plus 3 quantity squared, and that's equal to 5. And again, the beauty is when you complete the square, you get the square on the outside of the parentheses, which is very easy to deal with. And now we can square root both sides. So I'm going to square root you, and I'm going to square root you. And we get x plus 3 is equal to plus or minus the square root of 5. I don't know the square root of 5, so I'm going to leave it as it is. To finish solving this, I'm just going to subtract the 3 to both sides, and I get that x is equal to negative 3 plus or minus the square root of 5. Now I want to approximate. Now we're going to approximate. Let me get a better marker. That one's running a little dry. There we go. Now we approximate. Well, I know that the square root of 5 has to be between 2 and 3, and I mentioned earlier it's 2.4. That's what I approximated to be. If you said 2.3, 2.5, 2.6, whatever value is fine. Remember, as long as it's between the whole number of values, you should be okay. So we're gonna approximate the square root of 5 to be roughly 2.4. Okay, so now I have x equals negative 3. X roughly equals negative 3 plus or minus 2.4. So x roughly equals, or approximately equals, negative 3 plus or minus 2.4. Well, negative 3, you owe $3. You have $2.40. You're going to owe 60 cents. And if you owe 3 and you owe $2.40, you're also going to owe $5.40. So this would be how I would approximate a solution that does not have a nice square root. So I'm going to go ahead and check off the first goal, and I'm going to move into the second goal, how to deal with an odd b value. So I don't know if you've noticed this, but every b value has been even, so it's really easy to cut that in half. It would be a really good thing for you, the viewer, to see if you could draw this on your own when I put the example up there. So let me clean this up, set up the next example, and I'll be back. I'm back. So let's go ahead and continue this lesson, and we're going to get into our second goal, and that's how to deal with an odd b value. So here I have an odd b value that's 5. And so remember, when we draw a picture of completeness squares, we have to cut that in half. And think about 5 is $5. What's half of $5? And it's going to be $2.50. So it would be a really good exercise for you to hit pause and see if you can come up with the drawing that I'm going to come up with. And hopefully you do. If not, you understand how I came up with it, and that'll make this concept a little bit more relevant to you. So it's a lot easier. You get a lot more out of academics if you attempt and then see what you did right or wrong, rather than just watch and understand. So I'm going to go ahead and draw this, but you should hit pause. Hopefully you hit pause. All right, I hope you hit pause. So here we go. I'm going to draw this. There's my x squared. I'm going to draw a little bit larger than normal. There's my x squared. And my 1x, my 2x, and my half x. So there's an x, an x, and a half of x. And I'm going to draw the same thing off of this side. Okay? Because again, I have to cut 5 in half. Let me, I don't draw very straight lines. There we go. That's that x, x, and x over 2. All right, so I still have my 5 x's. I have 2.5 here and 2.5 there. There's my 5 x's. This side length is x1, 1, and 0.5. This side length is x1, 1, and 0.5. Okay. Well, I have two little squares. Two little squares. I have two little squares. So let's figure out how many squares that I need. And we figure that out by just extending the lines. And I'm going to use a different color so it's very clear what the squares that I need are. Okay, so now we just need to figure out the size of the squares. Well, I got a 1 and a 1, so that square has size 1. I got a 1 and a 1, that square has size 1. I got a half and a 1. 1 times a half is a half. 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 listen to how I say this. A half of a half is a quarter. Okay, so let's figure out what we need here. These two halves make 1. These two halves make 1. So I have 2, 3, 4, 4 1/4. I need to add 4 1/4 to what I have so that I may complete the square. So let me go back to over here and I'm going to add what I need. Plus 4.25 plus 4.25. Okay, so now we can continue with our process, and now it's no different. The only thing that's going to be different is figuring out these half squares and the quarter square. But hopefully that makes sense what I did. So here we have now x squared plus 5x plus 6.25. That's a terribly drawn 4. Let me rewrite that a little bit nicer. Is equal to 4.25. Well, I know the side lengths of this square. It's x plus 2.5, right? So here we have x plus 2.5 times x plus 2.5. Well, x plus 2.5 times x plus 2.5 is x plus 2.5 squared. And again, the beauty is I move the square off the leading term and I put it on the outside of the parentheses, which allows me to square root it away a lot easier than it would be to factor and such. So now I can square root both sides. Square root u, and I'm going to need a little bit more room, so I'm going to bring it up over to here. So now I get x plus 2.5 is equal to plus or minus the square root of 4.25. Well, my solution is going to be found by subtracting the 2.5 to both sides. Okay, so now I'm going to get x is equal to negative 2.5 plus or minus the square root of 4.25. Well, now I need to approximate it because I solved it. I got an answer, but now I need to approximate it. So the square root of 4.25 falls a little bit smaller than that and a little bit bigger than that. So we're going to say that the square root of 4.25 has got to be very close to 2.1. Okay, so now I have minus 2.5 plus or minus 2.1. So you owe $2.50. You have $2.10. So that means an approximate value for x would be negative 0.4 because minus 2.5 plus 2.1. And the second approximate solution would be you owe $2.50. You owe $2.10. So that means that you owe $4.60. So this is how I would solve a quadratic by completing the square when I have an odd b value. And again, I drew my x picture half the size. So hopefully that's making sense on how to deal with the odd. And you saw in the second example, I actually tied together both goals. Alrighty, I think this brings us up to current with the lesson. So I am going to end this here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.